Hey everybody, welcome to 13.4b. Today we're going to continue with finding inverse trig values, and we're going to focus on the other three trig functions that we didn't look at in 13.4a. So we're going to look at cosecant, secant, and cotangent today. So take a moment, make sure you have a note sheet out with the section, the date, and the I can statement, and then resume the video. All right, so the first thing I want to do is actually do just a little bit of quick review here, sort of as a brain wake up. I'd like you to pause the video and see if you can solve all three of these, and then resume the video as soon as you're ready. All right, so the tangent of negative square root 3, the easiest way, one way I like to think about this is essentially undoing the simplification. Because tangent, if we think about tangent, it's always sine over cosine. So this is really the same thing as the tangent inverse of negative root 3 over 2 over 1/2. If you really undo it and think about, okay, what did it mean when it was originally sine over cosine? So in this case then, the root 3 over 2 would be your sine value, and the 1/2 would be your cosine value. So we know that it has to have a reference angle then of 60 degrees or pi over 3. And tangent has an allowable range, tangent inverse is allowable range from negative pi over 2 to pi over 2. This one is negative, which means that the answer here has to be negative pi over 3. The cosine inverse of 2 over root 3, that's actually not possible because root 3 is smaller than 2. So when we divide 2 by root 3, we get a number bigger than 1. But cosine inverse has a domain between negative 1 and positive 1. So this would actually be undefined. And then finally, for sine inverse of negative root 2 over 2, root 2 over 2 has an inverse sine of pi over 4. And because it's negative and sine goes from negative pi over 2 to positive pi over 2, the answer here would be negative pi over 4. So that's just a quick review, just to kind of wake your brain up to these inverses before we dive into our three new trig functions we're going to look at today. We're going to start today by looking at cotangent first. So this is our cotangent graph. And again, we need to make this one-to-one, which means we need to restrict the possible domain for cotangent. And we're going to restrict it here, just like before, we're going to restrict this one using one cycle, so it touches every value and passes the horizontal line test. So we're going to restrict it from 0 to pi. So our restricted domain would be 0 is less than x, which is less than pi. And if you look at the range then within that cycle, this would go from negative infinity is less than y, which is less than positive infinity. So now if we think about the domain for this, for the inverse, remember that the inverse is just taking that original function and rotating it 90 degrees. And all we're doing is flipping the restricted domains and ranges. So for our inverse, our domain would become negative infinity is less than x, which is less than positive infinity. And our range would go from 0 to y, and note that these are not inclusive, or 0 to pi, I'm sorry. These are not inclusive because the cotangent function has vertical asymptotes, so the inverse cotangent function has horizontal asymptotes at 0 and at pi. But notice that our allowable range then is in quadrants 1 and 2 for cotangent. So let's look then at cosecant next. So cosecant, if we look at the original graph, obviously it doesn't pass the horizontal line test, so we need to restrict it. We need to restrict it so it includes every allowable value, but passes the horizontal line test. And the way we're going to do that is we're going to restrict it from negative pi over 2 to positive pi over 2. If we just take that section, it includes all the possible values, passes the horizontal line test, so our domain would go from negative pi over 2 to pi over 2, and note that this time it is inclusive because those points do exist. And our range in this case is a little bit weird because we can either be less than or equal to -1, or we can be greater than or equal to +1. So we have two different options, but not including the space between -1 and +1. So then our inverse cosecant is going to, we're just going to flip the domains and ranges. So our domain is going to have x be greater than or equal, or less than or equal to -1, or greater than or equal to +1. And our range here is going to be a little bit weird, because if we look at our range, and this is similar to our domain. So actually, I'm going to add in up here except 0, because I should have included that. Because 0 itself is on a vertical asymptote in our original function. Now it's on a horizontal asymptote. So really the best way to write this would be that our range would go from -π/2 is less than or equal to y, which is less than 0 because of that horizontal asymptote, and 0 is less than y, which is less than or equal to +π/2. So in other words, for cosecant, our allowable range is going to be in quadrant 1 and in quadrant 4, with the exception of 0 itself. So then finally, our last one here is secant. And again, we need to restrict our domain on the original function secant. So the way we're going to do that is we're going to go from 0 to pi, so we include every value and pass the horizontal line test. So in this case, our restricted domain would go from -π/2 is less than or equal to x. Now, in this case, when we, oops, I apologize, let me change that. Clearly it's from 0 to pi. So it's from 0 to pi, except we have a vertical asymptote at π/2. So we're going to go from 0 is less than or equal to x, which is less than π/2, and also π/2 is less than x, which is less than or equal to pi. And then our range here is going to be, again, we can, y can be less than or equal to -1, or y can be greater than or equal to +1, but it can't be in between. So then the inverse, we just take that original function in the box, rotate it 90 degrees, we can see our inverse. And in this case, when we look at our inverse, and I guess a better way of saying that would be, we're actually not rotating it as much as we're reflecting it over the line y equals x. So when we take that box, we reflect it over y equals x, we come up with our new inverse function. And the domain for this function, we can either be less than -1 or greater than or equal to +1. So in other words, our domain is x is less than or equal to -1, and x is greater than or equal to +1. Our range goes from 0 to pi, except π/2. So we can think about this as 0 is less than or equal to y, which is less than π/2, and also π/2 is less than y, which is less than or equal to pi. So our quadrants then would be quadrant 1 and 2. So this gives you the inverse domains and ranges for all three of these additional trig functions. So just to summarize this, and I think this will be perhaps the most useful aspect of this, if we think about going from all the functions that go from 0 to pi, in other words, the functions that include quadrants 1 and 2, those three functions, we're looking at cosine inverse, cotangent inverse, and secant inverse. These are the three that have allowable ranges for their inverse functions in the first two quadrants. And then if we think about the three functions that have allowable ranges in the first and fourth quadrant, that's going to be sine inverse, cosecant inverse, and tangent inverse as well. So these are what you'll need to keep in your head as you're going through and evaluating different inverse values. So let's try a few of these and see if we can start to kind of wrap our heads around how this is going to work. And these these ones are a little bit trickier because you really have to think about them backwards and think about the reciprocal nature of them. So for example, for the first one, if I look at cosecant of -1, or the cosecant inverse of root 2, I'm actually going to think about that. For me, it's easiest to think about this as actually the sine inverse of root 2 over 2 instead. Because all I'm doing is I'm undoing the reciprocal, but I also need to undo the rationalizing of the denominator as well. Because this is really sine inverse of 1 over root 2. And then I'm just like undoing that doing the rationalizing so I can make sense of it. So then if I think about the sine inverse of root 2 over 2, that one's a little more straightforward. That's just pi over 4. So I'd like you to pause the video, see if you can figure out the other 5 of these, and then resume the video as soon as you're ready, and I'll walk through these. All right, so I assume you've tried all these at this point. Secant inverse of 1/2, I'm going to think about the reciprocal of that as cosine inverse of 2. That clearly isn't within our allowable domain for the inverse of cosine, just like 1/2 isn't within the allowable domain of secant inverse. So this one would just be undefined. Remember that secant inverse has to be either less than -1 or greater than +1 for its inputs. 1/2 is neither of those things. Cotangent inverse, again, for me, the easiest way to think about cotangent and tangent are to think about them as either cosine over sine or sine over cosine. So cotangent inverse of -√3, I'm going to think about that as cotangent inverse of -√3 over 2 over 1/2, so that I can think about this as this is cosine and 1/2 is the sine value. So then cotangent, so I know this has to be have a reference angle of pi over 6, because that's what would make those true for sine and cosine. Cotangent is allowable in the first and second quadrants, and since this one's negative, it's going to be in the second quadrant, so the answer is going to be 5 pi over 6. For secant inverse of 3, that one is the same thing as cosine inverse of 1/3, which is not on your unit circle, but it is within the allowable domain for the inverse. So we can put that into our calculator to come up with the actual answer to that one. And if you put that into your calculator, if you were in degree mode, you would get about 70.53 degrees, or you could do it in radian mode. It doesn't really matter. And then, so cotangent inverse of 0, this one's interesting. Again, I'm going to split this into cosine and sine to help. 0 is obviously the same thing as 0 over 1. So I'd write this as 0 over 1, and I would think about this as cosine, and this is sine. So where on the unit circle is cosine 0 and or sine equal to 1? And that's obviously at 90 degrees, or pi over 2, which is within the allowable output for cotangent inverse, because it's between quadrant 0 and, quadrant 1 and quadrant 2. So then the next thing here is secant inverse of -2√3 over 3. And the key thing here is you kind of have to undo that in your head, because that's really the same thing as the cosine inverse of -3 over 2√3, right, as the reciprocal. But that's not something we're used to seeing on the unit circle. We're used to seeing this as the cosine inverse of -√3 over 2. Because all we're doing here is sort of like undoing that rationalizing bit a little bit there. And like these two clearly are equivalent, because if you multiply by √3 over 3, you end up with the other one. So then the cosine inverse of -√3 over 2, well, that just happens at pi over 6 is your reference angle. Cosine is allowable in the first and second quadrants, as is secant. So our answer here would just be 5 pi over 6. So the more you practice these, the quicker you'll get at them. It also is obviously dependent on how well you know your unit circle, which is why we've been practicing that so much. So again, your homework tonight will be another worksheet. So the worksheet and the answer key are posted for you. So try those and let me know if you have questions.